All right, for this activity, we have a simple airplane experiment. Now, the airplane experiments, if you've ever done one before, they can often be complicated by how kids throw paper airplanes, or more importantly, don't know how to throw a paper airplane. But a paper airplane experiment is, again, a design challenge that allows them to be able to work with a couple of these forces that you're talking about, whether it's gravity or friction/drag in this case. The variables are pretty easy and open, and the kids can then pick what they want to do. Typically, you have airplanes, you have two models. You either want the airplane to fly the longest it can, or you want it to stay up in the air the longest. The distance is typically the easiest way to go, especially if you have a tile floor. You use tiles roughly a foot, then you can just count tiles. You don't need to worry about meter sticks or whatnot, because sometimes these planes can go for quite a distance. So a long hallway is good. If you have an entire classroom to go from side to side, that's reasonable. You might have to then adjust how much force you apply to the airplanes so that you're not all just maxing out and hitting the wall. But I'll show you how to do that in just a minute. Probably the easiest thing to do with paper airplanes is to use what's called delta dart. It's the basic paper airplane model, and there's a bunch of different videos online to show you how to build one of those, and most of your kids, or some of your kids, know how to build them. So use that information the kids already have and group them by kids who know how to build paper airplanes and those who don't, mix them up so that the kids who don't know can learn from those who do. The delta dart is pretty much straightforward, triangular airplane, and what I usually do is I give the kids choices. They can either make multiple designs, so different types of paper airplanes, see which one's going to do the best job, or they can make the same design and build it out of different materials or at different sizes. So whether it's construction paper, copy paper, notebook paper, tagboard, or cardboard, for instance. Cardboard's fantastic. Tagboard works pretty well. It's a little thick. Or you do it a variety of sizes to see which one's going to give you the greatest flight time. The biggest problem is then when you get the kids to throw it. There's a lot of kids who throw it straight up in the air, straight down, sideways. They're throwing it super hard or not hard enough, and so you get a lot of variability in your data, and it makes it hard to kind of then see any of the actual conclusions. The way I fix that is I put a notch in my paper airplane here. So, and I reinforce this with tape, but it is just paper, and if you don't reinforce it with a little bit of tape along the edge here, it's not going to work very well. And then I take a ruler, it's got a hole in the front, and I attach a rubber band to it. And now I can use this like a catapult system on an aircraft carrier. And if I hold it by the back of the paper airplane on the bottom, I can then stretch it to a given distance. In this case, let's say 8 centimeters. So not that much. Okay. Now this also helps because no one is injured. Clearly, it doesn't go far enough. I got one, but probably a good thing with this one. And have the kids pull back a certain distance. So how many centimeters you want them to pull back. But what I was going to say is that it helps them focus by not shooting straight up or straight down when they're throwing, because they're not actually throwing, they're just pulling it back and aiming it, and then there you go. Now, I'm not aiming it far enough, I don't want to damage the laptop here, they're very expensive. But you can then let the kids change how much force they're adding to this. You can add weight to some of this, or whichever one, for instance. Let's say we do it in class, and they try a bunch of varieties, or they try a bunch of different papers, and then they see, oh my gosh, this is why they don't let me blow stuff up anymore, because I have motor control problems. So that one flew about 20 feet off screen. Once you come up with an example, you've done 3 or 4 trials, you've had them collect the data, and you see, okay, so the best design is, let's say, the delta dart with construction paper. That one's the best combined data for our results for this. And then you can say, okay, so let me see how many pennies can we add to this and still have a fly at a particular distance. So you can start looking at, can this carry cargo, for instance? And then you can think about where should I put that cargo, 2, 3 pennies, for instance, and how far can it go? So again, extending the design process and using these ideas of how much force should I have to add? Do I need to increase the force? Do I need to increase the size of the wings because I need to have it be able to support its weight better as it travels through the air? All these questions that are involved. And again, if you give them a design challenge and then just give them a few minutes to do it, you're cutting it short. Give them time to think about it. Give them time to go home and do some research. There's, YouTube is an amazing thing. They're watching it anyway. They might as well watch it and learn something about science. That way, instead of learning more about Fortnite or Minecraft, they can actually learn about paper airplanes, and they can come back. They will come back with some really interesting things that you have not thought of. When that's great, and then they can share it with the class, and you guys can build something better, and they can see how that knowledge was used to build something, solve a problem, how they improved on it, how they worked together to make those improvements happen. So that's paper airplane, straight and simple.